Okay, so let's start by saying what I did off stream. As always, off stream, I did some cleanup. Nothing too much exciting. Mostly, I've changed something in our event source aggregate. Mostly on instead of having a flat structure with tons of interfaces like event sourced aggregate args, ever sourced aggregate, reducer every source aggregate, whatever. I opted out for having just an exported X interface event source aggregate, and then I have a namespace which has its args, header, producer, draft, reducer, whatever. And that helped me clean up my typings, and that was really, really great. On to this stream, I want to fix some things that I thought in between streams about the implementation we did last time. If you remember correctly, last time we implemented an event journal storage that uses SQLite as baking strategy. And as you can see, it creates a table, allows the table to have any name we want, and then performs basically insertion wherever we want to persist something into the event journal. And if there are some error, we catch the SQL errors and we fail with an event journal open failed, or we die. And when we read, we just perform a select over the table for the aggregate root and ID we want to look by sequence. Okay, so the only thing that I thought that maybe I want to do a little differently, not too much, is the actual insertion query. The thing is that right now, the way I do it is basically I try to insert, and if I get any SQL error, like an insertion error, like a primary key that has been violated, that's a problem. So that's not great, because maybe if I type something like a wrong name of field, that will trigger as well an event journal append entry failed error. But I would like this domain error to be just in the exact case where basically you are trying to append an entry with a sequence and an entry with that sequence already exists. So we could do that in two ways. We could open the transaction and check if the entry already exists. And if it already exists, we throw them an error. And if not, we perform the insertion in the same transaction. But that would require a transaction and two queries. And I think we can do that in a single query by using something like insert into our table, the name of fields, and then instead of using values, we do select, and we just select the row values we want to append, like that. And we also add a subquery where not exists, and then we do something like select one from our table sql.literal args dot journal name, where, and here we have aggregate root equals aggregate root name, and aggregate ID equals, and we have aggregate ID and sequence greater or equal the one we want to journal entry dot sequence, the one we want to append. So that means that when we perform the query, we won't append anything if an entry with the same aggregate root, same aggregate ID, and a sequence that after the one we are trying to inserting already exists. that's not the most optimized way to do that, but it's still better than opening a database transaction and then performing the query. So now the thing is that this would silently fail if we have, for example, an entry that already exists. This will basically just don't perform the append, but that's not what we want to do. So we need to basically have a look at const results equals and see what this return. This is from a row, and maybe we have SQL dot. Let's see what the methods we have. Is there a method that executable? Let me see. We need to basically see which are the options allowed by SQL. Sorry. We need to have a look at Effect SQL documentation or rather the source and see how we can retrieve the amount of affected rows for the query. So let me check. We can do something like yes, GitHub. We can open here. Or sources. We can go to packages. Let's see SQL light node, for example. Test client. Inserting to that's just an SQL rows, maybe. Let me see. Is there a way to tell the number of affected rows? Packages, SQL, SRC. Oh, maybe. Yeah. Yeah. Got. Let's see. Affected rows. No. Insert. User interpolation. Mixed migrations. No. Let me check. SQL client. I make with the transaction, and then we have our SQL client, which comes from SRC internal client. Okay, and here we can see if we have a method for affected. We don't have that. Let's see, how can we deal with that? So maybe, it's something that it's database provider specific, because I could see some database provider not providing the amount of affected rows. Let's see. Let me check in here as well, because I think that ideally we could take a look at here. If we do dot row, I think that this returns unknown, and that's it, because result equals. If we try to put a breakpoint in here, I think that we will see a different result. Let me run our tests. Maybe that one in debug mode. Okay, we are hitting our previous breakpoint. Okay, let me check. Here we have result. Let's just step one in. Okay. Changes. Here it is. Changes. We have changes one. Okay, so we can do something like changes, or even better, dot row as effect dot effect, and here we will have changes with me a number, and then we have a possible error that could be as SQL error, and nothing as a requirement. Thing. Yeah, SQL error dot SQL error. There it is. So here our changes is a number, okay, and now we could say something like if changes equals 0. If we didn't append anything, then we can say yield star effect dot fail, and we can fail basically with this. And we fail with this. Now we don't care about that. We can save that perfectly. Let our tests complete. Let's try rerun them. They should run as fine. Changes is 1, so that's fine. Perfect. Our test is okay. And so maybe we can also add another tests, maybe, that says, let's go to the code and say this creates SQLite events. And then we can also duplicate this test and say fails SQLite append if already exists. Okay, and then fail. We provide a different name for the table that acts as journal. And then what we try to do is try to append this one 2 times, the same event 2 times. And then what we would expect is that if we take a look at the effect of exit of this one, append result, we expect exit is failure of append result to equal 2. So basically we expect to fail if we try to append the same event twice. And it seems that the test was successful. Let's try to run again that in debug mode and see with breakpoint we don't need anymore. Append result is a failure, and we have die defect. It's a defect. Oh, I know why it's the defect. Yeah, it's right. Because we said effect or die. And that's not what we wanted. Because we yield down an event and then we say or die. Yeah, that's not what we want. So we could say something like, when we do that, we return the changes. And then, instead of failing early, we do effect or die. And then we say effect dot plan map and say if the amount of changes is 0. So we didn't write any row. If we didn't write any row, then we won't fail. Otherwise, we would just want to say that sign do nothing. So this will say show any error you will have, and then any change you will have. If we didn't change any row, we fail because we expected. So otherwise, if we change at least one row, that's fine. That's exactly what we wanted to perform. So let's try to run again our test in here. Again, we run the test in debug mode and see, okay, append the result. Now we expect a failure. Perfect. And it's a fail. It's not a tag, and is exactly the failure we expected. Perfect. So maybe let's write the test in something like more interesting, more useful, like say expect exit dot the option. I think that was failure close option. Yeah. Oh yeah. I would expect that this is a failure. Yeah. And then we need to say that close dot. We need to import obviously the failure module from effect. That's failure option of append result dot if append result tag is failure, then we expect code to equal some. This can be some or none. Yeah, we want that to be some. Or equal true, even better. So option is some. So that way we tell that we expect to have some kind of failure. We need to import option from effect. Okay. And if we try to run again the test, that passes. Perfect. So that's one thing that I wanted to fix. It's nothing huge, but it's still something. And then, now that we have fixed that, we need to go back. And now the thing that I wanted to do is that we have written last time this interface that is an event-sourced aggregate that allows to read the state of one domain aggregate based on the events that have happened on that aggregate, or to update the state of the domain aggregate based on a function, a reducer, basically. And so what we need to do is provide some tests to ensure that it works as we expect. So let's write some tests for that. So here we'll say here new file event sourced aggregate dot test dot yes. We will obviously need some things in order to do the tests, like change aggregate, change product name, read product name, and here we have some things that we can reuse, like product being changed. Okay, so again, here, okay, we'll import something that we are missing, like import everything as aggregate root from our src aggregate root.js, and we need to import effect schema from effect schema. Then schema, obviously. Okay. I don't see any other missing imports. Perfectly. I don't care about queries for now. For now, I am focusing just on comments and events. Even not comments, to be honest. The event source aggregate is more about just events that happens on something, like a product can have its product name changed, or maybe we will have indeed like product created. That will happen the first time. Say that I want to create a new product, a product aggregate, and we will require a name and maybe also a unit of measure, just to create some test that it's more like what will happen in the real world. And then we have basically created our events and our aggregate. And now we need to import the actual model we want to test. Event source aggregate from src event source aggregate. Okay. And then we will see something like const product event journal equals events or aggregate dot make, and this requires few arguments like aggregate root, which is our product aggregate, and I think that is event types that are the possible events that can happen on that specific aggregate root. For example, we say just like you can have a product created or a product name changed. And then we'll have things like reduce. And reduce, what we'll do, before reduce, we need the actual state shape, which is the state of the product. And for now, we could say something like schema.option, and we will keep track schema struct, maybe, of product name, schema non-empty string, and also we'll have like unit of measure, schema non-empty string, and that's it. And now final thing, reduce, that will take state and our event that has incoming, or maybe a journal entry. So here we'll have few things that I have changed off stream. You will see immediately. You can see that here we have specified that the state for this domain entity of a product is an option. As I said, the option means that if it's none, the product doesn't exist. If it's some, then there is the product data. And that allows to create an impossible state that we cannot be represented. And then we have the product data of measure. And you see that here we have an option of an option. Okay. And that is because I decided that instead of having to provide an initial state argument, what we'll do is something like, if there wasn't any previous event, that state will be known. And if something has happened before, that state will be a sum, and the value will be the result of applying the previous events that have happened. So that means that, for example, in our case, we expect the product to have a first event of create product, okay? And then after we create product, then we go and we update data on the product. So we can do something like const product equals option dot flatten state. So that way we just get an option instead of an option of options. And now we can actually switch on the journal entry dot event type we have, and we can say things like case the product has been created. When the product will be created, now the state will be option dot sum, because now we have that journal entry sum, and we need to provide the product name. Will be journal entry dot event dot name. Oh no, unit measure, yeah. And then instead of unit name, just name. So name and unit of measure will be journal entry dot event dot unit of measure. Okay, so it's just basically copying the data over from the event into the actual state. And then the other thing that we need to do in here is handle the case when we rename the product. So case product name changed. And here we need to switch and say basically that return option dot map our current product. And if there isn't a product, we cannot change the name. If there is, then we will basically old product and say things like we'll copy over all of the old product, but change the product name to journal entry dot event dot did we forget to provide the product name changed? Yeah. Product name journal entry dot event dot. Why are you not happy with that? Let me check. Okay, that's you know what it is. Okay, that you know what it is. Product name. That's fine. Is it just new name does not exist on type product created? Yeah. And well, this may be a TypeScript bug, I think. Const product name equals. That is fine. Okay, that is indeed a type not a win bug, I think. Did I miss something in here? Case this const. Decoration. Return this. Why did you ask an unexpected lexical declaration in case? Oh, is that? Oh yeah, that's it. I didn't notice. Sorry. So maybe that will make you happy also about that. No, that's still a TypeScript bug. Okay, funny. Now we know. Okay. So still we now have basically the logic that handles that. You can see that our typings now are nice. We see that we have an event source aggregate for the product aggregate, and the state for that is an option which has the unit measure and product name, and then has product created and product name changed. Okay. So the other things that we get for free with this event journal based approach is things like created at schema.date, and you updated at schema.date, and that is because now we can say created at, and instead of passing into the event the explicit date time, we can use now the journal entry dot created at and updated at as journal entry dot created at. So now we also get for free the ability to track things about that. So here as well, we need to do update at journal entry dot created at. Perfect. Okay, so now we have our basically event sourced aggregate, and now we want to create some tests in order to ensure that everything is exactly how we expect it to be. So let's just copy from here because, I'm silly and it's easier to copy paste than remember everything. Okay, here. We need to close that, and then to close that, and then to close that. And then we need to import utils from effect vtest or vitest. Okay. Okay. We obviously need to import effect. And there is effect. And now we also need to write an actual test. So let's see. Here we are missing one curly bracket, and there it is. Okay. Okay, so let's say that we have defined our product event journal. So one test can be something like, let's say that we want to update that. So things like yield star product event journal dot produce. We want to change the product one, and the thing we want to perform, we have here a draft object that has append. I don't remember code. Yeah, we should add this is aggregate draft. Yeah. Then the draft is basically something that takes a function or returns an effect like append here, and we can just say append product created dot make, and here we now have to create our actual event. So let's make these more readable, maybe. And let me find gen function star. Okay. Const. Maybe we'll have something like product created event equals yield star equals product created dot make here. And you can see that here we have things like our actual needed data. And we need to provide in here as well the aggregate ID, which should be our product one. We need to provide also the unit of measure, like pieces, and the name of the product we want to create, and the product. Any product you want to create, chat, is something you want to create. Something like, I don't know, I want pizzas. As Italian. And still here, that's fine. Here, you can see that it's screaming at me because it wants an event journal storage, and we need to provide that dependency. So let's say that pipe effect.provide, and here we have to import everything as event journal storage from our implementation we did last time. Event journal storage here. And now we can do event journal storage dot in memory. So now that's fine. That's empty here. Yeah, here it's screaming because we created a variable that we actually never used. So we will just call append product created event. Okay. And then what are you screaming for? This generator function does not have a yield. Why it doesn't have a yield? The thing is that in here, in the arguments, I am missing this headers field. And this headers field is one of the fields that we have designed altogether in the first episode of the stream, if you remember correctly. And this has things like message ID, causation ID, expiration ID, and expiration. So maybe for tests, we can just manually type that in and say things like, we need to import everything as message headers from src message headers, and then we will create const message headers equals message headers dot make And here we'll see that the only actual required field is the actual message ID. Message ID. So here are our message headers. Then we can just rename maybe to headers. And then we can say in here, headers aggregate ID. Okay. And now that we have done that, these appends need to be yielded because that's an effect. Now TypeScript isn't screaming at us anymore. But it's right, we imported expect, but we are not expecting anything from this test right now. And what do we expect? Well, we have few things to expect. We expect first that here we append something into the journal. And then we expect that if we close journal entries, if we do something like event, if we call maybe from const event journal equals yield start event journal storage, and that will actually get the instance of the event journal const journal events equals yield start, and we will read the entire journal event journal dot read for the products, or maybe it's product aggregate dot aggregate name on the product one, and the events we're gonna have are, as we said, two that are product created and product name change, and we start from sequence 0. Okay, that is a list of a stream of journal events, ideally, if I remember correctly. Yeah. Avoidon is now assignable. Did I forget to pass in something? Let me check. Read aggregate name, aggregate ID. which is a string, the event schema, and from sequence. Yeah. Oh yeah, I'm yielding a stream. Yeah, I cannot yield a stream. Yeah, I can do things like yield star stream, and we need to import the stream from effect. Import everything as stream from effect stream dot run count, and that journal events count, and we can expect journal events count to equal 1. Okay, so now if we try to run this test, it passes, right? Perfect. So that means that we have written that perfectly the first time. Let me run that in debug mode to ensure that we actually get something. Yeah, that's perfectly working. Okay, so here we have a test that we change the product 1 and we append a new message of product created. And then we are successfully asserting that now we have did that. And then we can do other things like const current state equals yield star product aggregate dot read product event journal dot read, not product aggregate. We want to read for the product 1. Okay, and now that we can read the current state for product 1, we can see that, as I said before, can be an option of an option. And now the thing is that since we have appended a product created event, I'm expecting that this option will be basically an option of sum, and that inner option will be a sum as well, because the outer option says that no events has ever been received for these products, and the inner one says has been created or not. So we could say things like expect option dot is sum of option dot landen current state to be okay. Let us try to run in debug mode this test as well. Let's see what happens. Okay. Yeah, that should pass. Okay, and the current state is an option of an option. Nice. And we have our product, which is a pizza, and we have also our created and our updated that. And you'll see that the time is 000, and that is because the test service will basically adjust the time to be January 000. Nice. And we can also try to do other things about that. Like now we can add an additional change over the product and say things like here message ID 2, and we want a product name changed event, and say something like a new name will be like fancy pizza, and the old name will be something that instead we will read from the current state. So here we can say const product state product falsy option.flatten yellow star read. Yeah, that's nice. Yeah, because that read will return an effect of option, and then we have data, and here we have our option. Perfect. And we can say that option dot get or else product, or maybe even better, option product dot pipe option dot map. We need to take the product name. Okay, and if we don't get that, we can do something like do not provide any name. Okay, and here pacings. Okay, perfect. Okay, so here we are saying that we want to read the current state of the product, and if we have things like our message headers, we create for our second message, and this is not a product created by event, but a product name changed event of product fancy pizza. Okay, and now if we expect, if we do the same thing as before, we expect our count to be 2 because we have pushed a new event into the journal. So we expect that to be 2 right now. And then we could also say that if we read again the state, and maybe option of flatten here, option is some current state, and say if option if current state type equals some, then we expect current state dot value dot product name, I think. No. Current state, current state 2, because we have updated that. The state 2 dot value, yeah, dot product name to equal, it is fancy pizza. Okay. Let us check again that all of our tests passes. Here, debug test. Okay, this should pass again. Okay, here we have fancy pizza. Right. Nice. Yes, all the tests are passing. So here you can see that this kind of produce will be the de facto way for our application to perform changes over the state. And here, when we will use produce, we will do things like basically, if we can check the state of the current state of the aggregate, and then if we are trying to perform something that is not permitted in this moment, for example, changing the name of a product that does not exist, we can, for example, in here, go to the failure channel, and what will happen that failure will be bumped on the topper level of this produce. So we will get that failure and we won't write anything. Yeah. Yeah. So that is really nice and that really works. Okay. So let's go back into having a look at various things. So, we have seen that our element sourced aggregate work exactly as we expect. We have also improved our event journal storage so that we use select the insert into select where locks exist instead of performing other things. And then I think that for the core of the infrastructure, that is mostly what we would like to have, I think. That way, we have a way to persist event, and now we have also a way for that to be handled perfectly. Okay, so what can be the next thing that we can work on? Um, there is another thing that I would like to tackle, and the thing is quite simple. And maybe it's worth exploring today because it's still something that I would like to handle in my system. So the thing is that if you remember correctly, in our message headers, we have all of these fields like message ID, causation ID, correlation ID, and expiry. So those fields will be used later for various functionalities. So let's start by speaking about them, and then maybe we can start um, trying to do something that handles them in a more fancy way than manually handle them every time. So we have first a message ID. So a message ID is basically for now just a non-empty string, but to be honest, I want to use something like a UUID v5 or v7, v4, sorry, or v7. So one that has a timestamp built in. And then what will be used that message ID for? Well, it will be used basically to dedupe messages that are incoming into our APIs. So that way, if we try to perform, for example, the deletion of the same product twice, because the connection may go down while you send a request to the server, so you retry sending again that request, but the server now need to know if that request has already been performed or not, and if the request doesn't have an idempotency key, it won't be able to know if that has already been handled or not. And so that is related to the thing of having idempotency keys. And that means that how can we handle the most simple way would be to have a table or any storage that basically persists the result on any incoming request. And if it sees that has already been performed in X amount of time, then it will return the previous execution results instead of executing that again. And so that is basically just trying to read into database if we already have processed that specific message. And if we have, we return what we have stored in the storage. And if we haven't, we perform the thing. And then upon getting a result, we actually persist that result into the storage. Okay. So let's start maybe to tackle that aspect. I think, yeah, that is one thing that I would like to implement. So, um, mm, how can we call this trait? I can think that we will have basically two things. We will have something like idempotency storage, maybe. Oh, yes. Okay. And I think that idempotency storage will be API, will be an API that will have something like export interface, idempotency storage, and then he'll have things like handle, or maybe let me see. It can either go the way of check if already process, and then pass in the idempotency key, or we could go the way of and then having a second function that persists the result. That I think that for now would be the simplest solution. Yeah. So let's go like check, and check will take like idempotency key of type string. That's fine by storage. And maybe we will have also like consumer ID. And the consumer ID will be the ID of the consumer that is checking if already has performed and worked over that message. And finally, we need to know to have idempotency key, the actual schema for the result that can or will be persisted into the storage. So we need to import that schema as always. Fact schema. Sorry, it's fact schema. And then we will have like exit schema, something like exit schema will be like something like schema of exit. Exit of a any and no environment required. Yeah. So we'll have a consumer ID, which is maybe the product that is trying to consume the message, the idempotency key, and then the schema that will be used in order to decode the result that has been persisted eventually into the storage. And then we also need to save for consumer ID string idempotency key of string. We're gonna need the exit schema with schema of exit a E, and we obviously need to define that later. Okay. And we obviously say that A and E can be whatever we want. A, E can be whatever we want. And that will be the check will be basically an effect. Effects. And we can have maybe an option. And the option will return some if we have the exit already persisted, or a E, or none if we don't have that. And for the saving side is that I think that we will go on with just simple effect dot effect void first. Okay. Obviously, we need later on to handle some kind of errors when the idempotency storage goes on failure. But yeah, we will tackle that later, I think. Yeah, we will tackle that later. Okay, and okay, so quick recap. Well, a check method that checks if the given idempotency key has already been processed for a specific consumer. And we have the consumer ID, the idempotency key, and the exit schema. If it has, it will return some with the previous execution exit. And then we also have save method that will take the consumer ID, the idempotency key, the exit schema, and the exit as well. Exit, not exit, A, E, and these will do the job of this will persist into the storage the result of the execution of the comment, because we will mostly use that for comments. We will also use that for sagas and consuming events, I think, but yeah, mostly for that. And now that we have defined the interface, I think that we can actually implement those. Okay, so again, as always, we can start with the in-memory version, which means something like f.gem function stream. And then what we expect to do from the memory version. Well, the memory version, since we need to have something that, given a consumer ID and an idempotency key, will return an eventually already existing exit. I think that, again, we can use nested hash maps in memory to ensure that we already process that value. So first, maybe we import the ref module and say things like cons state equals yield star ref dot make, and we want to start from an empty state. So hash map, and have things like hash map dot empty, and that is the default state, because by default we won't have anything in memory. And one thing that we can do instead of explicitly using strings is that hashmap actually allows to index by hashable things. And in fact, we can use, for example, the data module to define hashable things. So we can say something like class in memory idempotency index extends data dot class, and we need to provide the shape for that, and we will have like consumer ID, which is a string, and idempotency key of type string. Okay. And now this can be an hash map that's empty, and the hash map will have as key in memory idempotency index, and as values you will use exit.exit or any, and that will be the storage memory we will use, so just a ref. And yeah, why did you want to import that as type? I don't know, but yeah, now we have created that. Now we need to implement the check and the save method. So let's start by the check method. So const check, that will be really easy. We can just say something like ref dot get state, and that will be an effect, and then effect dot map hashmaps dot get, and this check method will be of type idempotency storage check. So we'll have as parameters consumer ID, idempotency keys, and this schema we don't care because this is an in-memory version, so we don't care about the schema. But again, new in-memory idempotency index, and then we can say consumer ID and idempotency key, and that will get us back with our effect of option exit A. That's perfect. That's exactly what we wanted. And so let's try to do the const save method, which will be idempotency storage save equals consumer ID, and then idempotency key, and then the schema we don't care again because this is an in-memory version, so we don't need the schema to persist that, but then we need the exit value. Okay, and so we need to do ref dot update state and the state, and then we need to provide a function that given the old hash map produces a new one, and guess what? It's hashmap dot set on the C new memory idempotency key, consumer ID idempotency key, and the value will be just our exit. And this should conform to the signature we want. Effect void, nice. And then we return check and save. Okay, and finally we need to convert those into a layer. And guess how we can do that? Pipe layer dot effect, and we need to provide in a tag for our idempotency storage. And let's go back because if I remember correctly, last time we used the class syntax that allows you to define in the same line tag and also the shape. So let's do that again. So instead of export interface, we will do export class. And we need to import the context from effect. And we'll say extends context dot tag. and we need to provide a tag idempotency storage. Again, do not use tag like that in production in your application. You usually scope them by prefixing them with something like something like the name of your application. So something like add my app storage, whatever. But since we are just starting our application, we can care about that later and go with that for now. So we need to provide then the idempotency storage and the shape. And I think that we need to close that tag for that, call that function and that. Yep. Okay. And now back to our layer.effect, idempotency storage, and that's it. Here we need to change a little because now it's on type instead of directly accessing them. And this works. Okay. Okay, so now we have our in-memory idempotency storage. So now we need to create the actual idempotency utils that will use the idempotency storage in order to perform the business logic of idempotency. So again, idempotency will first check if already exists something for that specific key, and then we'll save if doesn't. So we will call that idempotency.ts, and we need to import everything as idempotency storage from idempotency storage. How do we want our idempotency to work? Well, I think that the simple API we could have is something like function that ensure idempotency. Again, if you have better names, you are more than welcome. That will take anything, and we'll provide a consumer ID string, and also idempotency key string, and then we'll have also a function, or maybe it's better to have an effect. We can provide an effect that will run only if idempotency hasn't been run already. So we need the consumer ID, the idempotency key, and also the exit schema. Again, we need to import schema. Everything is schema from that schema. Exit schema will be again something like schema. Schema dot schema exit exit. I'm not sure if we want to provide the entire exit schema or just failure and success schema. Let's start for now maybe with the entire exit schema, and then we can move from there. Let's see how it works in our own, and then we'll eventually move that into something more sensible for our use case. Exit any and no environment, because I don't want to handle that at the moment. And then we'll return something that takes in our text eventually, and then effect dot effect for everything as effect from effect effect of A E R, and we return effect dot effect A E R. Okay, so this is kind of the type signature that I am working towards. And the final value will actually require R, but also idempotency storage dot idempotency storage, because in order to make this behavior work, we need to use the actual idempotency storage. So this will be real simple, like 2 lines of code, and be something like effects.gen function star and say const previous exit equals and then we need to const storage or cl star. We need to first access the idempotency storage or idempotency storage. And I think that if we use service, ideally this should allow us to directly have APIs that calls that method. But yeah, storage dot check, and we'll check for the consumer ID. Consumer ID, and then we have also the idempotency key we need to provide in, and our exit schema, and this will return our effect of action perfectly. And then we need to yield that in order to get the option. Nice. And then we will say if previous exit dot tag is sum, for even better, we can import everything as option from effect option and say if option is sum previous text, we return the previous exit dot value, and that is one exit. But I think we can yield an exit, if I remember correctly. Yeah. Exit A or undefined. Why are you putting undefined? Oh, undefined because, we need indeed to return. And in case that didn't work, we need to actually run the effect. Okay. So this should be like we'll start, we need to actually run the effect. Okay. So let me check. We're still missing one thing in the behavior we want. So in the function ensure idempotency, for the people that has just joined in, what we'll do is that given a consumer ID and an idempotency key and the schema of the exit, what we will do is basically conditionally run an effect by checking if the idempotency storage has already a result for that effect or not. So let me just add yield effect. Here we need basically to add the persistence of that. So pipe effect dot on exit, I think. Yeah, on exit. Should that the class function whenever this succeeds, fails, or interrupts. Perfect. And on exit, this will be the exit, and we need to journal storage, dot save for our consumer ID, we need, and our idempotency key, we need, and our exit schema, we need to save our exit. Okay. And we are golden, I think. The exit will type A or E, exit schema, idempotency key, consumer key, whatever. Okay. So that will work. And we'll ensure idempotency for our computations. But right now we have only one in-memory storage. And I think that an in-memory storage won't be enough. At least we need to provide a persistent one, because upon restarting our application, we will need to make sure that our idempotency is still valid. So again, we can maybe start with SQLite based one. And that could be based a table as well. And the table will have primary keys with number, the consumer ID, the idempotency key, and then eventually return the value. And so let's maybe just maybe we can try to just copy the one we did for our event journal storage. The one for SQLite we are basically looking to build something really similar to this. This only appends and reads, and that one will read just the first record. So maybe let's start by copying this one and see what we are able to accomplish. Okay, so few things. Okay, it maybe this one will have something like export namespace, idempotency storage, and then export interface args. We'll have just the idempotency table name. Idempotency table name, perfect. We don't need to do that. Our idempotency table will be something like idempotency storage SQLite row will be something like how did I call that? Consumer ID. And then will be idempotency key. And then we will have the exit payload. Okay, we need to import everything as SQL client from, in fact, SQL client. Okay, and this will be, our args will be idempotency storage.args. You can see why I really like using the namespace. And then create table if not exist, create the idempotency table if not exist, create table if not exist, idempotency table name. We said that we have consumer ID, idempotency C, and then we have the exit payload, and our primary key will be the consumer ID and the idempotency key. Perfectly. Okay. And then we have our methods. We will start with the save one. Will be idempotency storage type save. Okay, and we will have our consumer ID, and then our in here, sorry, rename symbol, our idempotency key, and our exit schema, and our actual exit. Okay, so first of all, we need to know to create the exit payload, which we'll do again. What we'll do is take our exit and encode that into a string. So this will be like a string perfectly, because we used, this is our schema, which is a schema of an exit. And then we used the parse JSON combinator that combines a schema in a way that it changes the encoded side to be a string, and basically JSON decodes the string and transforms that into the encoded shape of an exit. And then we encode the value. So with that, get that. And then we perform the actual insert. And I think that here, I don't know if I want a domain error for that. Maybe we can start with that and maybe change later. So insert into journal table name, and we'll have our consumer ID, idempotency key, and an exit payload. So select consumer ID, exit payload, where not exist, send up one from not journal table, but it's called idempotency table. Idempotency table name, where consumer ID and idempotency key, and we do not need to perform a check over the sequence. Okay, and we expect to get a changes or number of records changed. That will be a number. Okay, and then we do a factor die, and if we fail, we have a idempotency for now. Maybe we can just say or die, and that's it for now. Yeah, and maybe I'll change that later. Yeah, let's start with or die. Yeah, we are missing. We need to remove the type from import schema. Okay, and we need to change also that. Okay, so our save method should be okay, I think. SQL error, right? Need to import SQL error. Import everything as SQL error from effect SQL error. That's it. And that's the save method. Save instead of append. And then we also need to create a check method. Idempotency storage check. Again, we have not an aggregate root, but we have a consumer ID. We have an idempotency key, I think, yeah. Idempotency key. And we have, I need to remember the next shortcut for renaming symbols. I have to, yeah, I need to change that key binding, exit schema, because, yeah. Okay, select everything from idempotency table name, where consumer ID equals that, and idempotency key is the one we want, and I don't care about the order by, because we expect only one record to exist in that table. And I don't remember if there is, utils for yeah, that's right. That row is fine. Yeah. Okay, that row is fine. And here we had streamed out from iterable. Yeah, that's not what we want. What we want to do here is something else. If row data dot length it is less than 1, return option that none. We don't want nothing. And otherwise, we want to decode our row. So const exit will be like yield star, and we need to perform the decoding. And schema.decode parse JSON of exit schema. We need to provide the actual value we want to decode, which will be row data dot row 0 dot exit payload. Okay, and that will be our exit of type A. Yeah, perfect. And then the only thing that we need to do is, I think, we want to give an yield star exit, and that should return as the thing. We want actually to return an option of the exit. Option some of the exit. Yeah. Okay. Why are you complaining? Parser scalar is not a good. Never. Yeah, because we said that the way we have defined those interfaces, we don't want domain errors. So I think that for now, we can just say dot pipe effect or die. Nice. And then that will be our check method, and that will provide the idempotency storage layer. Nice. Okay. So I think that we are ready to write some tests that will check that this is working exactly how we expect. And then I think that after that, we can close our string. And let's see. Okay, so let's try some tests. New file, idempotency storage.test.ts. Okay, those are very similar to this one, I think. Yeah. So this one, yeah, we can just copy that one. Again, those services are really similar, but they do quite different things. We could do that both for the memory one and yeah. Okay, that, and then we need to close that and close that. Okay, so those are the tests for the idempotency storage. Okay, ship persist, then read result. Okay, and here instead of importing event results, we need idempotency storage. Rename symbol idempotency storage. Idempotency storage, and that is storage, and then we need to call storage dot save, and consumables will be, let's say, products again, or message one. It will be more like something like products one in an ideal world scenario, and the schema will be like schema dot exit of, let's say we have success of type schema dot number and a failure of type schema dot string. Okay, and we finally need to provide the actual exit exit dot succeed for teacher. Okay. Okay. And here, why are you complaining for? You're complaining because you think that events, we don't want to do that. We just want to say something like previous result equals, and then we will do just like storage.check for products, product 1 and message 1. Again, we should maybe put that into something like more cons exit schema, so we can reuse that. The fact is missing. Yeah, you're right. The fact schema dot 3 unknowns. We don't expect the fact, but in case they happen, exit schema. Here we need to then read by exit schema, and then we expect option dot is sum previous result to equal true. Okay, and that should work for the memory one. But if we copy that one and do the same thing for this one, and hit differentiate different consumers. Okay, so let's say that we persist into products 1, but then we read products 2. I expect to equals false to is none. Okay. And finally, we have the one that actually uses SQLite. So this will be like idempotency storage dot SQLite. Yeah. Idempotency table name. Idempotency. And we need to provide SQLite node. Yeah, we have perfectly. Okay. And finally, I think that we are almost cornered. What are you missing? Oh yeah, it's calling things that does not exist. Yeah. Here we need to call that. Okay. And then we expect, in this case, we expect previous result to be expect option is some previous result to equal true for product swap. Okay, so let us work all together into what we expect those tests to do. Let's clean up some code, and then we can go through them to see if we have written everything correctly. So, should persist, then read results. So we expect that given the idempotency storage, we have an idempotency exit schema. We expect to have the ability of saving for a consumer products 1, message 1, say the exit schema, say the X has succeeded with the value 42. And then if I try to read the value that we have just persisted now, which I expect that to be true, And also I should have that if we have a previous result and that is sum, I also expect that exit is success, previous result not value to be true. And the same goes if we try to save with a different, for example, consumer ID. So we save with the products one, but then we read for the products two. I expect that to be known because we are reading a different consumer. So the idempotency key is consumer based. The message has an ID, but the consumer, Mattia, may already have seen that message. Another consumer may have not seen that message. So we need to keep that storage based by the consumer, then the message ID, and then persist the result. And finally, we do basically the same thing, but with an SQLite file. So we start by clearing out the table name, so we don't have records from previous execution. And then we perform a persistence, we read, and we expect to read. So let's try to run them. First one succeeded. Second one succeeded. Last one, failed. Idempotency storage dot parse JSON is not a function. Yeah, we have some errors. Schema. Why did you decide to rename things? I don't know. But yeah, I will try to make you more happy. Oh well, man, it changed name everywhere. Schema. I don't know why he decided to change names. Well, I can quickly go through and fix them. Here, schema. I don't know why it happens sometimes with the rename feature. Well, yeah, I get that getting correctly that function in TypeScript is hard. Yeah, the test worked. So let's try to run that in debug mode to see that the values are what we expect. Okay, here we have a delete, we storage, we persist, get the previous result as an option, and the value, success, and the value is 42. Yeah, nice. Nice, really nice. Okay. And let's try to have a look at our database. Now we should have, we have multiple tables, as you can see. And if we do things like showing the record for this one, you should see that we have that. Nice. And event journal fail, we have the data for that. And we also have the data for the other one. Nice. Okay. So we have seen that our idempotency storage works the way we expected. And so I think that the last thing that I'll do before closing the stream is performing tests over the actual idempotency feature that we have just built. So this one basically. And I am not happy with the name, but maybe we can try to write some tests and then find out if we find out we have a better name. Maybe we'll just ensure, since this counts from the idempotency module, calling that ensure idempotency is redundant. Okay, so let's try to write some tests just for the idempotency module. Oops, sorry. Here, idempotency.test.ts. And then we will start by grabbing everything from the previous test. And here we will remove that one. Okay, and keep just the SQLite ones. Really, we can just use the in-memory one. Yeah, we already have tests for the SQL storage. I don't see the need of over testing those, so we can have simpler tests. So we need to import everything as idempotency from SRC idempotency. Okay. And then should run if never happened before. Okay. And we can use ref in order to see how many times our competition has been run. So let's say that we have our exit schema, number, string, effect is okay. We will keep that, but now we will say something like const test one will be something like ref dot update and get. We first need to create a ref, const state ref equals yield star ref.make will start with 0. And now I will delete all of these just to make TypeScript. Let me leave with the wiggle things. Okay, we create a state ref. The schema of the exit will be XSS in a number or sphere string or defect unknown. And we'll start by say something like our computation will be like ref dot update and get state ref, and we'll do something like increment by 1 and then getting the value. So this is an effect. We won't yield this effect. Okay, we'll use that effect for those tests, and we'll say something like const run 1 will be like pipe computation, and then idempotency dot ensure for consumer message 1 and exit schema. Okay, we would need to import, I think, pipe. Yeah. Okay, this is an effect that returns a number, may fill with a string, and as an idempotency storage as a requirement. And now I expect that, and maybe this computation can be reused multiple times, but yeah, like that. Okay. I expect first run, I expect that if we yield this one, run 1, okay, I expect first run to be 1. And I expect that because on the first run, what will happen is that this idempotency key for this consumer has never been seen. So from 0, we'll increment to 1 and then get the value. So only a value 1. And then second run, I'll start run 1 and expect again the first run to be 1 again. The second run, sorry. Okay. And it seems that our tests are functioning. So let's run that in the back. Here, first run, we run our competition. It's 1 perfectly. We can also try to put here a breakpoint like there and run again and see that won't be run. Nice. But if we try to run again our test, we will see that if we still have, it moved away my breakpoint, but yeah. What I wanted to show you is, that on the first run, we get into the breakpoint, and then we won't get into the breakpoint again. Nice. That is exactly what we wanted. So let me just clean up by removing that. Still don't, and do not run again twice. Okay. But then if I do something like run 2 and use a different idempotency key, I expect that third run to be 2, because now when we run again with the second idempotency key will be different, so we'll actually run our effect. So yeah, it works. Nice. Okay. Okay. What can we do now? We have our event source aggregate. We have our idempotency. I think that next time we can finally look into actually having APIs finally. I understand that maybe what we did into the streams up to now are maybe more architectural things, functional things, that will be used by the platform. But yeah, next time we can move definitely more into those APIs. And I think that maybe since we have some time right now, we can start doing some cleanup of features. But yeah, for example, one thing that I would like to change a little is that in our idempotency storage right now, in the SQL version, we do a select, and then we do an insert when we actually perform the insert. But what we will change eventually into is something like inserting the record anyway, and then locking it by updating, for example. That way we can, for example, perform this logic of idempotency in a transaction and ensure that that idempotency check will update one field into the table in a way that will lock the record, and we cannot then have two different idempotency being run on the same entry if we're on a transaction, obviously. Because checking, we update that, and then we update this count field, for example. And then when we actually save, we just date one record. Yeah. That would be one thing that we'll do maybe next time in the, Okay, so I think that the only last thing that I would like to tackle maybe is, first of all, run all of our tests and see, okay, we are still running everything perfect. And we also have tests for the server, which we are not using for right now, because right now we have only worked on the domain part, but yeah, we will eventually also work next time, as I said, on our server part. You can see that we have errors in here because the APIs have changed a little. The HTTP APIs of Effect are still something that is quite in the beta phase, and they are on small reworking on how they works. But yeah, I think that could be interesting for our application since this is a greenfield application. It's an application that I won't be paid for. It's something that I will use in one association that I am part of, as I described in the first episode of our streamings. And then I think that using something that is unstable is fine by me right now. But still, we can open some discussion on how we want our APIs to work for next time. So, let's me check. Yeah, maybe we can leave this as an opening for next time stream. And this better, yeah. Okay, I think that with this, we have done quite a few things today. We have implemented our tests for our event source aggregate. We have seen that it is working the way we expect. We have also implemented an idempotency storage and an idempotency trait, and we have provided features for that trait. So I think that for now, I am really pleased on what we have done. And so I will thank you all for whatever we have did today and for tuning into the stream. Again, thanks again for the awesome feedback on the first recording that has been published on the Effects Videos channel. Again, please subscribe to the Effect channel on YouTube to get notified whenever a new video gets published. And well, with that, thank you again for your time and hope to see you next week on Thursday, I think. Yeah. Okay. Thank you very much again. See you next time. Bye bye.